So this is also some kind of a part too, because actually I already presented the Erlang Doctor tool, I think 2 years ago at a meetup, something like that. So yeah, it's also kind of a continuation. So what you can see, like on the right, is actually these are the docs. If you're curious, these are the hex docs for this tool, which means that it has docs, which is good. So yeah, let's start from an example. But in this case, this example is like half of the presentation. So yeah, please pay attention because it might get a bit complex. So I have been working on an open source XMPP server. It's a messaging server like for the last 12 years or something maybe. And it is an open source project, and we do have issues on GitHub, as open source projects do. And one of those from this year was really complex, I'd say. So under some not quite clear circumstances, the message archive could contain duplicated messages suddenly, and it was only reported by one user and nobody else. And this happened with so-called stream management extension enabled. That's all we knew actually. And there was some initial investigation of this problem, but actually the user only knew that when he like reconnects a lot of times, then probably the issue is more prevalent, and our team was unable to reproduce it. Everything was fine when we tried similar scenarios. Logs showed nothing. Everything was fine, also on that user's side. So yeah, what's the problem, right? Actually, I have a tool for that job, and this is the tool called Erlang Doctor. And actually, despite the name Doctor, I'd say that it's more like this tool, this stethoscope on the right. It's not that it is the doctor which will tell you what's wrong, is that you have to be the doctor and use this tool. That's the thing. So this is very lightweight. It's a lightweight tool built on top of maybe. Yeah. Yeah, this presentation is AI free. Yeah. Well, yeah. Yeah. So this is very lightweight tool, and Erlang has this tracing built in, so it builds on top of that. And what it does, it is collecting the traces in an ETS table. And when they are in ETS table, well, firstly it's quite low impact because you just save something to the ETS table, that's it. And the second thing, you can query them later and analyze them. And the querying and analyzing, this is the main feature, let's say, of this tool. So just a few notes about the tool itself. It is for Erlang and Elixir. For Elixir is called XDoctor, and which sounds like he was a doctor, but now he's not anymore. Yeah, yeah, it's a bit funny. So you can run it in three different ways. There is this like firefighting snippet, which is I think quite useful when you don't have it and you suddenly want it. You can just get it from the internet and run it instantly. It's a one-liner. You can get it from the repo. Then there's like a development snippet, which I use all the time, which is I just put it in my .erlang or .iex, something like that. And then you can finally package it with your software, which we also do for this Mongoose IAM server. So yeah, let's start. So what happened here is that we asked that guy on GitHub, we just gave him like a few lines of instruction how to use Erlang Doctor. And what he did was he started tracing actually all the, let's see if this works. Yeah, it works. All the modules in this application, in Mongoose IAM application, all function calls, everything. And then he connected and disconnected that user app that was suspicious and triggering this bug. and then he just stopped the tracing when he had enough of the traces, when he knew that the bug was there. He checked it in the database, and then he dumped the traces to a file. There's a function for it, and it was 2.5 gigabytes. Like, yeah, not great, not terrible, but yeah. Then he simply shared the file with us, and then I could do my job. So let's start the Erlang Doctor. It just starts as a process, and then let's load the traces. So now we have them locally in our ETS table. By the way, I also have the Mongoose IAM server loaded, and that precise version, just to be able to have the data, to have stuff like, for example, record definitions from that from that version. So yeah, I will use some records here. So let's read some record definitions from both Erlang Doctor and from the server, and let's start. We want to identify the duplicate message. What we know is that every single message that gets saved to the archive goes through this function. That's like basic knowledge of the server. So what we are doing here is that we are doing a statistics of function calls. This is one of the basic features of Erlang Doctor. So there is this call stat function, and you provide a fun, and this thing is the key for the statistics. So this will be a direction if the message is incoming or outgoing, and the message itself. And what we get is, as a result, is a huge map, but actually we are only interested in the top entry. So let's only get the top row of that statistics. And what we got was that there is a message duplicated 7 times, and the message is incoming, and then there is the message on the right. This is XML because XMPP is XML. So this is a decoded XML element. Okay, so next question. Who archived that message, right? Because there is duplicated message. Who did it? Which process? So now we create another statistics, very similar, but two things different. First one, we are only interested in that very message that we want, that is duplicated. And then the key is the PID actually. So we get the statistics by PID. And the first number is the count. So the first process archives 1 message, the second one 2, and the third one 4. Okay. Well, let's save the PIDs of those processes for later. By the way, the receiver PIDs, why I'm calling them like that? Because every message has a sender and recipient, and actually in this case the recipient had crazy amount of sessions open, which was actually the problem with that client. So here we have 3 sessions of the recipient of the message. So why did those processes archive the message? Well, what I'm doing here is that I'm using yet another function of Erlang Doctor, which is traceback. So this will give me like a traceback of the first function call that matches that function, right? For that the function returns true for it, and this is like a predicate, and we are interested in this message. So from the bottom, right, from the beginning, firstly, the so-called C2S process terminates. What is a C2S process? It's a process responsible for client to server communication. So it's a client-server process. And, sorry, client session process, that's what I meant. Then a so-called SM buffer, a stream management buffer, is rerouted. Well, it's a bit technical, but this buffer is actually collecting so-called unacknowledged messages, so we make sure they don't get lost. But actually, in this case, they were very far from being lost. They were duplicated many times. But yeah, still, the logic does its job. So each buffered message is like rerouted, not to be lost, and then it's routed locally. Finally, the message is archived, which is actually the first bug. And it was very surprised to me that so early I got the first bug. because actually this message was already archived before, before it even got to the buffer, and this is already a problem, and I was able to fix that bug pretty easily actually. A special marker was missing from the message. I don't want to dive into details, but next question: why did those processes terminate? Right. So let's examine so-called, I call it like that, the roots of those tracebacks. So I'm only interested in the root. So I'm adding this here, and I'm only interested in the root of the traceback. Okay? And I'm seeing that the root of each of those sequence of calls was replaced by new connections. So actually, the client was opening so many sessions that they exceeded the limit of maximum sessions, which is 10, and the new sessions were just terminating old sessions. So yeah, the client is doing something crazy here. But still, we don't want this duplication. So let's see what we can do. Well, another question is how many copies were in each of those buffers. Let's see. So from those archive roots that I just presented in the previous slide, from those root calls, I can extract that buffer from inside. Of course, I need to look at the code for a moment to do that, or look at those traces a bit in more detail. But actually, yeah, it's not that difficult. I could get those buffers from within. They are large, but what I can show you very simply is to count the number of that duplicated message, this one, right? And count the number per process. So the first buffer contains 1, the second one contains 2, the third one contains 4. So we know that each of those processes had that message already duplicated in the buffer. So, but as I said, this is like one of the most difficult cases for me to use this tool. So we still have a few steps to do. Another one, next one, like how did the message even end up in this buffer, right? So a question would be like, who routed them to those processes? Okay, yet another call. So I'm interested in traceback, and this is quite interesting. Contains data. It's kind of sometimes I'm calling it last resort, but not always. It's like, let's look recursively in all the traces, anywhere inside maps, tuples, lists, wherever, and find that very buffer that I'm interested in. It will be like the first function call that created that buffer, or that added the last message to that buffer. So when I'm doing this, actually I got pretty good results, because I got handle events. So it means that all three recipient processes simply got the messages with this like info route arguments. These are the arguments of that function. Data is arguments here. So let's just look inside. Let's just look here, right? Let's look inside. So I looked inside and I got 3 messages, but actually they are different, which might be surprising. It's not like the same message 3 times. They are a bit different. That's because actually the first process got the message from the original sender, and the other 2 processes got them rerouted. And when you reroute a message, you add the from attribute. So, or even, yeah, before that, but you add this from attribute. So actually we have 2 messages, original message and message, the same message, but with 1 attribute difference. And finally, after this step, we can reconstruct the order of events, and we can see who sent the message to whom. So I identify the sender receiver pairs. This is the last step. Yeah, tr filter is another function, and this is actually a simple one. It gives you all the matching traces, and you just provide a predicate. So the predicate is the PIDs has to be in the receiver PIDs, that's the destination PID, and the message has to be one of those. Right, so then I do a bit of processing here, and I print out the 3-element tuples. So this is the first three are actually the original sender. This is, by the way, the new process. We haven't seen that before. This is a new process. This is the original sender session. And all the rest are recipient sessions. So firstly, original message sent to the three recipient sessions, and then the recipient sessions just send the message between themselves in a pretty crazy way. So let me show it on a sequence diagram, and I think this one will be readable. So the sender, yeah, easy. Now the recipient has three sessions, also easy. They had more, but the three sessions are interesting. Firstly, sender sent the message. Why to all three of them? Yeah, because that's how it works. The message wasn't addressed to one of them, it was addressed to any of those. So all three sessions got the message. And buffered the message because the client wasn't handling the acknowledgement properly. That's the problem. Then the first one terminated and sent the message to the remaining two ones. So actually, this one has already two copies of the message. You can see it, right? Two arrows. And then, actually, what happens when the second one terminates, it already has the two. So it sends duplicated message. So this one has four, right? 1 + 1 + 2. And the crazy thing is that it could continue. And I was able to replicate it in tests, like 16, 32, yeah. Yeah, it was possible. Yeah. So yeah, this is it. This is how this debugging worked. So I just wanted to show you how you can use such a tool in pretty complex scenario. I mean, it wasn't easy. So the causes are firstly the misbehaving client, which is completely misusing the stream management extension, completely misusing it, and two bugs on the server actually. And I reproduced both in tests, and then because we do test-driven development, and then another pull request was to fix them actually. So yes, this is the first part of the presentation. Now the second part is I had numerous of those cases like this one over the years. So yeah, I kind of specialize in this. So yeah, now, how could you make your program easy to debug? That was my question, right? And Erlang is a functional language, so let's try to keep things as functional as possible. And what I mean by that is that functions should be pretty short, pretty simple, so that when you're in a function, you kind of know where you are in the step of, like, in the process of execution and your logic. Then I'd opt to have like either side effects or logic, like heavy side effects and heavy logic. Combined is probably not the best thing. Then I'd avoid like super complex steps, like when you have imperative logic, functions that are super long. Probably not the best thing. Conditional expressions, I learned that if you nest a lot of them, it's then more difficult to debug where exactly you are. You would need the line, but yeah, maybe it's the best not to have too much nesting. Then list and map comprehensions, if they get very complex, they are really bad to debug and really difficult to debug. I will show you an example in a moment. And I'd avoid like heavy logic inside, like nested begin end. If you have to do that, probably it's better to split it into functions. And when you have the logic inside an unnamed function, it's kind of difficult to trace it. So I'd name the functions and name them intuitively so that you know where you are exactly when you know the name of the function. So let me give you an example. There is a list comprehension, and I wanted to clarify that I have nothing against list comprehensions. I'm using it also, but it's just an example, right? So it's not bad. I wouldn't say this code is bad. It's like you have so-called tasks, let's say, and each task has to be like the list contains tagged tasks. So firstly tagged then a task, and you have to prepare each task. Then you get like tuple with context and job, okay? And in a nested list comprehension, we get the operations from a job and perform each of those. Okay, so we do it in nested list comprehension because we want tag the results. We want this tag. Okay, and actually when you run it for a simple like 2 tasks with 5 operations inside, you get these function calls. And actually those 3 are nasty in my opinion, because it's kind of difficult to decrypt what they are doing. Of course you can look inside the implementation of list comprehension, you will know. But actually, from my experience, it's pretty crazy. I mean, the numbers of, especially the number of times they were called, like it's 3, 4, and 7. It's pretty difficult to tell. Why 7, right? You would need to think about it. And there is an alternative. I would do it this way. But of course, there are many ways in between, and it's not, you know, it's not set in stone. But let's have a different version. And here, of course, it can be list comprehension. It will be also okay. But I'm using list map. That's because it's a simple map. We are not using any advanced things like filtering or stuff. So let's use list map. And I think this is important. We have a function for perform one task, right? It's a separate function. And for me, it's cleaner. It looks a bit cleaner. But actually, when you look at local functions being called, it's this when you run it. So you have this function, which is so easy to understand. It's like exactly 2 times. It was called 2 times for each task. It's when you trace it, you will get the name of the task. Like everything will be much cleaner than above. So yeah, it's more traceable, more debuggable. Another example, but okay, one thing. If you have only this list comprehension, is okay. But I've seen code when you had like 4 of those, and then you have the function number 15 something. So when you debug it, it's crazy. It's really crazy. And yeah, another thing, like heavy logic in begin end. So let's say you have this list comprehension and you have begin end, and then like 15 lines of code. You imagine that they are like 15 lines of code. Yeah, not perfect, right? Maybe what are alternatives? Maybe this use a function. I don't know if it's better, but yeah, I mean it's nice that there is a function, and probably the name of those functions would be as crazy as in the list comprehensions. But yeah, maybe you could do it in another way. There is this option. I think it's pretty nice because this dispatch item, actually, it's more variables because there's a long function name simply. But this one like tells you what it's really doing. So I think that it's good that all the complex logic is like encapsulated within one function. And when you know that like in your error report or anywhere, there's this name, you know what we were doing, dispatching an item. Okay. And there is also this option, which is to use list for each. Why it's interesting? I think because of this, that we are not interested in the result. When we are not interested in the result, for me, like the natural option would be lists for each, unless I have to do some filtering. Then list comprehension would be nice with all those extra expressions or guards, let's say. Yeah, so these are the alternatives. So whole system, in my opinion, one more thing, like deterministic logic, because we've had many flaky tests because we are testing a distributed protocol, and we have thousands, literally thousands of tests, and some of them are flaky. So I've learned that it's good when you produce always the same response for the same request, of course, if no other conditions changed. What I mean by that is that, let's say the specs only say that you have to return messages A and B to the user, and no order is specified. In this case, my opinion is you have to decide on the order. Do not let it be completely random, because you are sending an A and B to the client. Let's say in 1,000th of all cases, you send BA instead of AB. And let's say that client crashes in that condition. And they will crash very, very randomly, and it will be almost impossible to reproduce. So if you can, it would be great to have this AB order like set, even if the specification doesn't say so. And I'd say dividing into applications, probably nice because you can identify, okay, the bug is in this application. It's not always that easy, but I'd say it's good like to have reasonably sized applications. And yeah, a few other notes. Shipping debugging tools, especially if you are expecting this system to be complex, like Recon, like Erlang Doctor, Mamaitu, and there are others as well. You can ship them with the app. I mean, they are not heavy, and it's not a problem. And then maybe they might be useful for some firefighting, and avoiding debugging. Yeah, this is kind of more like philosophical. If you instrument the code with logs, metrics, and maybe distributed tracing, as we've learned, open telemetry and others in the previous presentation, maybe they will help us find out what's going on before you have to resort to this kind of digging inside the traces. And good coding practices, yeah, follow them, have like good test coverage, yeah, normal stuff, and yeah. I mean, that's it from me. This picture means that that's the end. Thank you. Yeah, so maybe we have questions.
So I have a question. Will you share these slides on meetup.com?
Yeah, I can share the slides.
Because I remember that the previous presentation about Erlang Doctor that you gave, like I don't know, a year ago or something, was very informative. I think that this is a bit shorter, at least the how to use it part. And I think that either this or the previous one are way better than the documentation itself.
Okay.
Examples on what to do and also about the problem.
Okay.
And I'm not sure if the previous slide deck was shared, but I would really.
I'm not sure, but yeah, I will. Okay, I will definitely do that. I'll make sure to share them.
Yeah, because I think it's super useful, but not super easy.
That's right. Yeah.
Thanks.
Why there was only one user that has this problem?
I think there was a second case of it, but it manifested in a completely different way. So they didn't know, and I think we fixed both at once. But I think that the problem was that that user had enormous number of sessions. Like the client was, I think, every 30 seconds of something, it was connecting another session, and it wasn't closing the sessions. Yeah, there was some fault if that guy was simply still developing their client app, and it was like not closed. Something was wrong with the logic on the client side. It was completely different language, different. So I don't know. I don't even know the code. I don't know what it was.
Mostly like that is a misbehavior of the client app that results in this pre-connection cycle, which is not the one that you normally have in a real life, or when you just have non-malfunctioning app. But anyway, the bug on a server is a bug on a server, so you still have to fix it.
Yeah, the problem was that this guy was having like this intermittent failures, and only after, I don't know, 2 months or 3 months, he learned how to reproduce it so that he could send the traces. Because for a long time it was like, after 2 months I suddenly got duplicated message.
It's not really helpful.
Yeah. Yeah.
I have a question. By the way, I do use this library for every problem I
Okay.
have. I love it.
Oh, thanks.
That makes it super useful.
Thanks a lot.
Every time I have to use it again, because you don't have to firefight this hard debug thing.
Yeah.
So every month it's like, okay, Erlang Doctor, how was it that I use it? Then every single month I have the same question: what is a trails bug? Because every month I have to check it again and again to try to understand the function tier traceback. Why
Ah.
traceback? What is the meaning of that word?
I mean, I found I found that name traceback like used in Erlang documentation, I think. So I used the same name. But what would you stack trace? What?
I'm just trying to look, okay, which one is the function that I need?
Okay.
And I get confused with some of the names.
Yeah, I definitely could be better with naming. The stack trace maybe would be a better name. I could change it anytime, right?
2 words. Trace something back. So from the function you pass as an argument to the top.
Yeah, to the root, yeah.
And why is the root?
Like the root call, that's the very first call that originated all the sequence of
Okay, yeah, okay.
function calls.
Official documentation avoid using the stack trace term simply because of the tail call and optimization. So
Okay.
technically not the stack trace. Yes.
Yeah, exactly. Exactly. And it's interesting because here when you enable the tracing, the tail call optimizations get disabled actually, right? So actually that's the main reason why your app might suddenly consume crazy amounts of memory when you use this tool. That's why I don't advise using it in production. That's the main problem, because that tool is about tracing everything. I mean that's the main feature of it. Like I don't want to make up my mind which function to trace. I want to trace everything. Of course you have to limit it, so I limit it to one application. You can limit it to like 2 modules or something like that. But yeah.
I think it disables tail call optimization for the functions where you enable tracing.
Yeah.
Those functions that you don't enable tracing, they still have it there. And if you have some like code, non-traced code in the middle, then this one will not be. It can have tail call optimization, and then it's not a stack trace anyway. So
Yeah.
those bits can be missing.
Yeah.
I think it's also worth to mention that you, in Erlang, especially, you rarely have the option to address the user to tell him to run some Erlang commands.
Yeah.
Right? If you use Erlang in backend, you have no possibility. You have to do it all yourself, right? So that's the point.
Yeah, I mean, I don't know if I understood it correctly, but you can ask the user. I mean, it depends if they are comfortable with Erlang shell, right? Because
If you have tool that works on his machine, but if you have something only on your server that end users don't have access to, then
okay, this was because this wasn't end user. This was someone developer basically. This was a developer. He was still developing the client application. Yeah. Okay, so I think that's it, right? So thank you.